So I'm gonna talk about archival discovery in the age of AI. So how to use AI to discover and explore archives. And I'm going to do so proposing a very concrete solution that of evidence link retrieval using large language models. And you might find an implementation of this idea already online, and I'll put the link also. Oops, sorry. I'll put also the link in the chat if I can. Okay, this is the this is what I wanted to show you. So it's relay.cdch.dk. And in there you will find more information about what I'm going to discuss. So the idea of evidence link retrieval comes from obviously a widespread need in archival discovery and exploration. So we know very well that knowing what a collection contains is and where the relevant material is a large part of the business of archives. The reason why we try to keep them in their original ordering, for example, or we develop finding aids to access archives. All these are means to get to the relevant material and information. And when we are thinking about using AIs to access archives, that need remains there, obviously. And it is not as easily solved as we might think. For example, if we decide to train a model, an AI model, large language model, on archival materials, then that model is going to be able to reply to an extent based on the contents of the archive. But it will not reliably be able to refer back to the sources that it has used to provide us with an answer. So effectively, we have answers that are detached from the sources. And we know very well that when we use archives, when we do research with them, this is absolutely not what we need and what we want. And the solution is instead to use a different approach, to require that every answer that a large language model provides us is to be grounded in the corpus that it uses. For example, an archive. So we need to have answers that are linked back to the passages that they draw from. This enables several things. So it enables us to trust in the answer because we can easily go and verify the sources that have been used. And it enables us to guarantee that the provenance of the information that we are provided with is actually actionable. So we are able, with a click, to go back to the sources and check what they contain. And I would argue that this is an essential requirement for using large language models in archival discovery and exploration. So how do we do that? This is the point of Relay. Relay is a research tool that we are developing at the Center for Digital and Computational Humanities at the University of Copenhagen that embeds several techniques in order to reach this end goal. Now, you might or might not have heard about retrieval augmented generation. This is a technique that is widespread, widely used in order to provide large language models with information that they can use to give us an answer. Even if you don't know about this, you might have used a large language model like ChatGPT or Claude or Copilot and uploaded some documents to it in order to ask questions about them. So retrieval augmented generation is what happens behind the scenes when you do that. And the same approach can be expanded at the collection level, so to thousands or even millions of documents. And this is the core of the technology of Relay, but we have added much more to it in order to make it absolutely as reliable as possible. So how does it work? Well, imagine you have an archive and you want to be able to ask questions about the contents of this archive. So the researcher or whoever is doing it asks questions about the collection. And the first thing that the system does is to try to better understand what the user is asking about. Some users are very thorough and they ask very complete questions, but other users, they ask very short questions. So the model also needs to make up for those gaps. Then the system goes and finds relevant contents within the archive. This is an essential step that is called retrieval, and it can be done in many different ways. And how it is done in Relay is using what we call a hybrid approach. So a hybrid approach combines several techniques from semantic embedding techniques that basically take the contents of documents and transform them into vectors that we can search with. Traditional techniques coming from information retrieval, and also other techniques of navigating information in ways that mimic how we read analog contents, for example, like the table of contents of a book. So a combination of techniques to do retrieval. When the system has found the relevant passages, then it uses them to give more grounding to the large language model, so that the model can use that in order to provide us with an answer. Once we have an answer from the model that uses the grounding, then we go back to the sources and we verify each claim in the answer against the evidence. So this is a formal check. We call it a formal check of correspondence between the answer and the sources. And this is done in order to, I wouldn't say completely eliminate, but significantly limit the problem of hallucinations. So made up contents that, read correctly, but they're actually invented. And this system is now under use at the University of Copenhagen. So we're using it internally to support a variety of tasks, research tasks, especially in humanities research. So people working on corpora of variety of different contents, from literature to actually archives and the like. And we're also working with external organizations to roll it out to collection level. Systems. And this is proving to be extremely effective because it really provides trustworthiness to the system, because the users can always verify that every claim is actually grounded at the statement level in the sources that have been taken up by the model. So I think this is the main point that I want to make, is that when we are thinking about using large language models for archival discovery, obviously a lot can be said and done in terms of generating generating new contents based on what the collection contains. But I would argue that the main problem that we need to solve for is that of grounding. So we need to think about how to reliably provide the information that is relevant to give a certain answer, and that comes from the contents of the archive, to a large language model. And when that is done, then we can create a system that is able to make that connection explicit for the user. So being able to move back and forth the answer and the sources that have been used. So verification and actionable provenance of the contents. And in this way, we have a system that is much closer to the scientific approach that humanists have to archives, or anyone that works with an archive actually likes to have. So being able to go back and forth and always check the evidence. So this is work that is ongoing. There is a lot of research going on in this space, and it's quite very exciting. And again, it's a different approach from training a model on the contents of the collection. You don't need to train anything. You can use any model that you want. Actually, small models, they work very well with this kind of approach. You can keep everything on premises, we say, so within your organization's perimeter. And still have that high reliability that I was talking about. So if you go to our website, relay.cdch.com, you will .dk, you will find more information about it, and you will actually also see a tiny example of how it looks like in practice, with this statement level possibility to go back and forth the answer and the supporting evidence, and being able to check it with the system actually flagging for you the passages and the contents that might warrant further verification before being considered reliable.